All right, we're going to continue talking about like terms and simplifying algebraic expressions. So we talked a little bit about like terms with our previous set of notes. And so some of this might be a repeat, but the thing that's different, I think, on this one is they're throwing in some distributive properties. So the last couple of lessons are now going to be combined into one. Alrighty, let's just read through this. Again, some of it's going to be a repeat. It says parts of an algebraic expression are called terms. We put that on our vocab from last time. Identifying terms and like terms. Remember that terms are separated by addition or subtraction signs. So this has 4 terms. And then the like terms would be the ones that have the same variable. So these two have an x, these two are constants without an x, and so those are like terms. Let's see, some more stuff that we learned last time. Like terms are terms that have the same variables raised to the same exponents. And we know that constant terms are also like terms. All right, so here is an example that they've started for you. And we will continue the example. So they took this expression, and the first thing they're going to do is distribute this -2. So they're doing -2 times g and -2 times 4. This 7g does not get multiplied by the -2 because the -2 is outside the parentheses, which means it's only going to be multiplied with those terms inside the parentheses. However, don't forget about the 7g. It's there. It's just not being multiplied by the -2. So their next step is to actually carry out that multiplication. -2 times g is -2g, and -2 times 4 is -8. And then we have our 7g. Now we're going to combine like terms. I have a -2g and a 7g. Those are like terms because they both have a g. -2 plus 7 is 5, so 5g, and then plus that -8. And I showed you last time how a more common answer is just going to be 5g minus 8, because 5g minus 8 and 5g plus -8 are the same. This just is less writing and the more accepted way to write that answer. Let's take a look right here where it says an algebraic expression is in simplest form when there are no more like terms and no parentheses. So if you're wondering, how do I know when I have it all the way simplified? That's how you know. No more like terms left to combine and no parentheses. All right, so we have a few examples down here that we're going to do next. And they go in order from easiest to hardest, which you would expect, right? All right, so this example number 1, we're going to circle the like terms. Remember to include the symbol in front of each term. And I like to use lots of different colors. Or if you don't have different colors, you can use squares, circles, and triangles, or underline it once and then twice. Somehow identify the like terms. So for this one, I have 2 terms with a g, so 12g and -5g. 12 minus 5 is 7, so I have 7 g's and then the 4 at the end. Remember that we always want to write our terms with variables first and then our constant last. You could also just highlight like terms. Just remember to include the symbol in front, so like all the a terms, those are like terms, and then you could use a different color for your constants. Don't forget about the symbol in front. And so for that one, we have 4a minus 9a. 4 minus 9 is -5. And then 8 plus 6.2 is going to be 14.2. And look how I put the a term first and the constant last. And the last example has some distributing. So it's like the first example that they started for us. We're going to take the 3 and distribute it through the parentheses. So we're going to have 3 times 5b plus 3 times 2. And we're not going to multiply 3 times -4 because the -4 is not inside the parentheses, but we don't want to forget about it. So now we're going to actually multiply them. 3 times 5b is 15b. 3 times 2 is 6. And then we're going to find our like terms, which you probably already spotted are the constants here. So there's only one term with b, so I'll bring it down, and then 6 minus 4, of course, is 2. Alrighty, one last example here, a word problem. Yay, word problems. Write an expression in simplest form that represents the perimeter of the polygon. Hopefully you remember that the perimeter of a shape is adding up the length of every side. So we're going to add 5m, x, 6m, and 3x. I just went around and wrote down each side and added them together. And then we're going to find our like terms. So we have 5m and 6m. And our other like terms are x and 3x. So our simplified expression will be 5m plus 6m is 11m. And remember, if there's not a coefficient, it's actually a 1. So 1x plus 3x is 4x. And we also talked about last time how most of the time we're going to write an expression with variables using alphabetical order for the variables. So is it wrong to say 4x plus 11m? No, because you can add in any order. But generally speaking, we want to write, I'm not going to mark it wrong. If you write 4x plus 11m, I'm just trying to show you the way that your algebra teacher down the road is going to like you to write the answer. So thanks for watching.